Unit 7 Biomechanics in Sports and Exercise Science 7.3 Angular motion. Angular motion is the movement of a person or object around a fixed point. For example, when a gymnast does a somersault, their body rotates around an imaginary axis. Angular kinematics is the study of rotational motion of objects around an axis, focusing on key concepts such as angular displacement, angular velocity, and angular acceleration. For example, in high jump, when they rotate over the bar is an example of angular motion, and then the angular kinematics is the focus on the angular displacement, velocity, and acceleration. Angular kinetics is the study of the forces that cause or influence the rotational motion. For example, what causes the rotation in high jump over the bar? Planes and axes. Axes are real or imaginary lines at which the body rotates around. For example, in a hammer throw, your body rotates around an imaginary axis going through the body from top to bottom. Planes are an imaginary flat surface running through the body. For example, when doing a cartwheel in gymnastics, the athlete does it on a plane that splits the body from front to back. There are three types of axes: the medial lateral axis, the anterior posterior axis, and the longitudinal axis. The medial lateral axis. The medial lateral axis is an imaginary line that runs horizontally from the medial, the inside of the body, to the lateral, the outside of the body. The movement that takes place on the medial lateral axis is flexion and extension. For example, in football, when they take a throw-in, extension takes place in the elbow at the medial lateral axis. The imaginary axis in this sporting example would run through the elbow joint, as this is the pivot point, horizontally from the medial to lateral. Another sporting example could be in football, when a player goes to kick the ball, extension takes place at the knee joint in the medial lateral axis. As the axis runs through the knee, the joint and the leg pivots on this point, extending the leg, leading to the ball being kicked. Anterior-posterior axis. The anterior-posterior axis is the axis that runs horizontally from the anterior, the front of your body, to the posterior, the back of your body. The movement that takes place on the anterior-posterior axis is adduction and abduction. For example, in football, when a goalkeeper reaches out and dives for a save, abduction takes place at the shoulder joint. This takes place in the anterior-posterior axis. The imaginary axis in this sporting example would run through the shoulder joint from the anterior to posterior, as the shoulder is the pivot point. Another example would be when a gymnast exits a cartwheel, their legs close back together due to adduction at the hip joint. This takes place in the anterior-posterior axis, as the axis goes through the hip joint, allowing the leg to pivot at the hip for the gymnast's legs to close together. Longitudinal axis. The longitudinal axis runs vertically down the body from top to bottom. The movement that takes place at the longitudinal axis is rotation. For example, in shot put, when the athlete turns and throws the shot put, rotation takes place at the trunk and the longitudinal axis. The imaginary axis in this sporting example would run through their trunk from top to bottom, as the trunk is the pivot point. Another example would be in tennis, when a tennis player hits a forehand ball and puts spin on it. Rotation takes place at the shoulder joint. This takes place in the longitudinal axes. The axes would run through their shoulder and in line with the arm, allowing them to rotate to put spin on the ball. Sagittal plane. The sagittal plane splits the body from left to right, splitting the body down the center from top to bottom. The movement that takes place in this sagittal plane is flexion and extension. For example, when in football, taking the throw in extension takes place at the elbow in sagittal plane. Another example could be kicking a football, because it takes place in the sagittal plane. Frontal plane. The frontal plane splits the body from front to back. It splits the body down the center from top to bottom. The movements that occur in the frontal plane are adduction and abduction. For example, when a goalkeeper dives to make a save and reaches out, the arms abduction takes place at the shoulder joint. This takes place in the frontal plane. Another example would be the execution phase of a cartwheel. When the gymnastics legs close together, adduction takes place at the hip joint and in the frontal plane. Transverse plane. The transverse plane splits the body from top and bottom, splitting it horizontally. The movement that occurs at the transverse plane is rotation. For example, during a shot put through, when the athlete spins to release the shot put, rotation takes place at the trunk in the transverse plane. Another example would be when a tennis player does a forehand shot and puts spin on it, rotation takes place at the shoulder in the transverse plane. Each plane links up with one axis. The frontal plane links with the anterior-posterior axes, the sagittal plane links with the medial-lateral axis, and the transversal plane links with the longitudinal axis. Center of mass is an imaginary point at which the weight of an object or a person can be considered to act and is equal on all sides. The position of the center of mass is different depending on the size and shape of the person or object. For symmetrical objects, like a football, the center of mass is directly in the center of the object. However, in a non-symmetrical object, like a person, the center of mass is different depending on the shape and size and is wherever the weight is distributed equally on all sides, and it can even go outside the body. For example, a football's center of mass will never change as the football never changes shape and its weight is equally distributed. However, with the person, as they can change the shape of their body position and redistribute their weight all the time, their center of mass is always changing. Another characteristic of center of mass is balance. Balance is the ability to stay upright and maintain control over the body. Balancing becomes easier with the more points of contact you have to the ground. Your base of support is also what helps you balance, and that's how wide apart your points of contact are. The wider apart they are, the lower you are, the more stable you'll be. Line of gravity is the gravitational force pulling you down and goes vertically through your body, going through the center of mass. Athletes can manipulate their center of mass to optimize their performance and balance. For example, in gymnastics, when they are balancing on the beam, the athletes try to keep their line of gravity in line with the beam, but sometimes they lose balance and have to sometimes manipulate their center of mass to stay on the beam. Like if their center of mass goes outside of the body and their line of gravity is not in line with the beam, they will start to fall as they have an uneven weight distribution. They can rebalance by manipulating their center of mass, by sticking their leg out the opposing way they are falling to redistribute the weight and bring their center of mass back in line with the beam. Another example of an athlete manipulating their center of mass is in high jump. In high jump, athletes can manipulate the center of mass to increase performance levels at the takeoff phase when they jump off one foot and moving their center of mass closer to the side they are jumping to. This then creates angular motion once they have jumped, allowing them to jump in a curved motion over the bar. Stability is the ability to maintain control of your body in a given position or moment. Stability can be increased with more points of contact and lower center of mass and a wider base of support. For example, in gymnastics, doing a headstand is a lot easier than doing a handstand. This is because you have more points of contact and it also has a wider base of support, meaning it's more stable and easier to balance. Center of mass can be manipulated by athletes to increase and decrease stability. For example, in rugby, when a rugby player is about to get tackled, they would widen their stance and squat down low to lower their center of mass. This will make them more stable as they have a wider base of support and a lower center of mass, making them harder to tackle. Levers are how movement is created in the body at the joints. Levers are made up of four different components: the fulcrum, the load and the effort, and the beam. The beam is the bone which provides the arm for the movement. The fulcrum is the pivot point, which is the joint. The load is the mass of the object that is being moved. The effort is the applied muscular force. There are three types of levers: first class, second class, and third class. First class levers consist of the fulcrum being in the center of the lever and the effort and load on either side. First class levers are movements of extension. For example, in rugby, when throwing the ball in a line-out, the upwards phase, when extension takes place in the tricep, is a first class lever. The fulcrum is the elbow, and the load is the rugby ball, and the effort is the applied muscular force from the tricep. Second class lever consists of the load being in the center of the lever. Second class levers allow the movement of plantar flexion. For example, at the start of a 100-meter sprint, when the athlete pushes off with their foot due to plantar flexion, the ankle joint would be the fulcrum, the load would be the body weight, and the effort would be the applied muscular force of the gastrocnemius. Third class lever consists of the effort in the center of the lever. The movement that occurs is flexion. For example, in tennis, when doing a forehand serve, flexion occurs at the elbow. The elbow is the fulcrum, the load is the tennis ball hitting the racket, and the effort is the applied muscular force from the bicep. Mechanical advantage is the ratio between the effort arm and the load arm. It is calculated by effort arm divided by load arm. If it is bigger than 1, it is mechanical advantage, meaning more weight can be moved and there is more range of motion and speed of motion. If it is below 1, it means it is mechanical disadvantage. Turning effects. Torque is the force that creates the twisting or rotation movement. Internal torque is muscles applying muscular force to move bones at a joint. External torque is torque not in the body. Torque can be affected by magnitude, direction, and location. The gymnastics analysis. Angular motion is seen in gymnastics during the event of the asymmetric bars. As the gymnast swings on the bars, angular motion takes place as the gymnast moves around the fixed point in a circular motion. When doing a vault in gymnastics and the gymnast straddles over the vault, abduction takes place at the hip joint during the upwards phase of the straddle. This takes place in the frontal plane and the anterior-posterior axes as the axis runs through the hip joint and the athlete's legs pivot round the joint upwards, leading them to straddle the vault. When the athlete does a forward somersault when doing floor work, flexion takes place at the knee joint. This occurs in the sagittal plane and the medial lateral axis as the axis runs through the knee joint, allowing the leg to flex and tuck in a ball to somersault. In gymnastics, when doing a round-off on floor work, rotation takes place at the trunk. This occurs in the transverse plane and the longitudinal axis as it allows them to rotate around so the body can make it around to land the round-off. In gymnastics, when on the beam, athletes try to keep their line of gravity in line with the beam and their center of mass inside their body. Sometimes things don't go as planned, so they need to manipulate their center of mass by extending out a part of their body to rebalance. In gymnastics, when they do a headstand, they need stability to stay upright. They do this by widening their base of support. Also, by having 3 points of contact helps balance, and they have a low center of mass to increase stability. In gymnastics, when the gymnast does a vault, extension takes place at the knee to push them up in the air, making them jump. This is a first-class lever as the fulcrum, which is the knee, is in the center of the lever. In gymnastics, when doing a handstand, the gymnast needs to point their toes to stay as straight as possible. This is done by plantar flexion at the ankle joint. This is second-class lever as the load which is the weight of the foot, is in the center of the lever. In gymnastics, when doing a somersault during floor work, the athlete must tuck their legs in close to their body. This is done by flexion at the knee joint. This is a third-class lever as the effort, which is the hamstring, is in the center of the lever. In gymnastics, whilst on the asymmetric bars, when they are swinging around, they apply force through their hands whilst rotating around the bar. As they change their body position, their arm is affecting the torque.